All right. All right, y'all, let's go. So like I was saying before I left, we're going to get all the way to graphic, determining the X and Y intercepts graphically, and I'll devote the beginning of the class period tomorrow to talk about determining the X and Y intercepts algebraically, okay? All right. First things first, let's talk about interval notation. Now, you all have been dealing with inequalities since elementary school, right? When your teacher drew the little corny alligator and stuff on it, right? And said the alligator's always eating the bigger, if it, eats the bigger number, right? Another way you can look at it is the smallest number is being bullied. It's always being pointed at, like, haha, you're small. Okay, right? A bully. All right. But that's inequalities. How do we convert this to interval notation? What the devil is interval notation? Let's first talk about a few things, okay? Now, when you want to include a value, okay, I'm going to speak specifically about how to handle this inequality. But initially, understand this. When you want to include a value, you use a bracket, okay? And the inclusion of values, okay, will always be connected to less than or equal to and greater than or equal to inequalities, right? Okay, Kendall, hands up, come. All right. If you see that line underneath, okay, that literally says less than or equal to, right? Emphasis on the equal to. Or greater than or equal to. Emphasis on the equal to. If you have the element of equality, you will use a bracket on your interval. All right. Now, in that same vein, okay, when you want to exclude a value, hold on. I got a typo there, but it's okay. When you want to exclude a value, okay, when you want to exclude a value, you will use parentheses, okay? You will use a parenthesis. And that, of course, will be used when you don't have the element of equality, where you're only dealing with less than and greater than, okay? Now, let's turn the inequality x is less than 2 into an interval. Heaven, you with me? You don't look like it. Take them shades off because you look like you just, you feel me? All right. So the first thing we're going to do, young people, is we're going to draw a number line, okay? Draw a number line, just like this, straight across. Okay? And boom, I'm going to put 2 right smack dab in the middle. Now, do not get bogged down with putting all of these dashes on here and labeling all of these numbers. It's so unnecessary. I'm going to do it just to be funny. I got 2, 3, 4, 5, 6, 7, 8, 9, 10. And going this way, I got 1, 0, -1, -2, -3, -4, -5, -6, right? All those numbers, it's really not necessary. Now, let's be mindful of something, just graphing the inequality itself, right? When you don't have the element of equality, okay, the circle on the graph, okay, or the dot on the number on the graph, okay, you're going to have an open point, open dot. Okay, it's going to be open because I'm not including the value. But when you are including the value, and we talked about this first semester, when you are including the value, you're going to have a closed point, right? A closed dot. Coming back to you? All right. So look at the inequality we have here. X is less than 2. Do we have the element of equality? Do we have the element of equality? Kendall, do we have the element of equality? Where is it? How do you know if an inequality has the element of equality? What will it have? Your little self just be back there knowing everything and won't say nothing. Y'all, Valeria did like this. When I asked the question, how will you know if an inequality has the element of equality? Valeria said, what does this mean? What will the inequality have? No. What will it have underneath it? That little line, right? Which means what? Which means equal to, right? I didn't hear you, babe. I'm sorry. When you said it, you were absolutely right. Forgive me. Okay? So am I going to have an open dot or a closed dot on 2? It's going to be closed? Because we just said it's going to be closed. It's going to be closed when you have a situation like this. So is it going to be closed? It's going to be what? It's going to be open. Kendall, I need you to pay attention, baby. Open dot on 2, right? Open dot on 2. Can y'all see that? Now, which way am I going to shade? Well, tell me this. Where are the numbers less than 2? What does less than mean?
Numbers less than 2.
Where are they?
On the left side.
On the left-hand side? All right. So I'm thinking I should shade on that side. Y'all want some color pencils? So I should be shading on the left side, right? Make sense? So see if your graph, when I get back, see if your picture looks like mine, right? You want something?
Thank you.
That's colors for y'all. I'm just kidding. All right. I did take the best color. Don't tell nobody. Okay? You have to find some orange and green. There you go. All right. So which way should you be shaded? Savannah said to the left. Marion said to the left. Let's see. All right. Naturally, the numbers to the left of 2 is where the numbers are less than 2. Okay? How we feel? But we still haven't done interval notation, have we? All right, y'all see this arrow right here? That means keep going that way, right? Well, what is the smallest number that way? Infinity? Positive infinity? Thank you. The smallest number I can conceive is negative infinity, right? It's a concept, really. It's not an actual value. You should be writing, everybody. Kendall, I'm going to give you a swim cap. and tuck all your hair into it. Get your hands out of your head, child. Pick your pencil up. So when we're writing an interval, young people, you start with the smallest value of numbers that you want to identify, okay? We just shaded all these values to the left of 2, didn't we? Okay? But that arrow means that I'm going to what value? I'm going to negative infinity. Now, remember, you start your interval with the smallest number. So let's write down negative infinity. I'm writing my interval, remember? Negative infinity. And don't get bogged down if your infinity is ugly, okay? If it's ugly, that's okay. The more you draw the symbol, the less ugly it will be. Okay? And I'm starting out at negative infinity, and I'm coming all the way down, and I'm stopping where? At where? Say it louder. 2. Yeah, stopping at 2. Now, I got to decide if I'm going to use brackets or parentheses, right? Well, they said when you want to include a value, use brackets. When you want to exclude a value, use parentheses. Well, am I including 2 or excluding 2? Huh? I'm including it? If I was including it, y'all, wouldn't the circle be closed then? Am I including 2? No. Make sense? Oh, Lord. Bless the teacher. Y'all, I tried to erase the dot and I'll just draw it back. Bless the teacher. So I say it again, baby. So I use parentheses. So I use parentheses on 2, right? Boom. But what about negative infinity? Well, can I ever reach the value of negative infinity? Nah. Young people, you will never place a boundary on infinity or negative infinity. Okay, so when you're writing interval notation, Michael, when you're writing interval notation, Alexis, when you're writing interval notation, you will always have a parenthesis. And I rarely say always, y'all. Very rarely say always. You will always have a parenthesis on infinity or negative infinity or positive infinity, because it will never end. There's never a boundary that will be placed on infinity. Because if you say, I know what the smallest number is, I would say, oh, you do? Subtract 1 from it. If you say, I know what the biggest number is, I said, oh, you do? Add 1 to it, right? No such thing as the smallest or biggest number. All right? All right, may I proceed? Let's do a practice problem. Y'all got it? You cool? All right. Here we are. A different type, rather. Okay? This is a compound inequality. In the same wheelhouse, in the same vein. Okay? So here we go. We have to write in interval notation the following inequality. -4 is less than or equal to x, which is less than 9. So really what this is saying is the value of x is between which 2 numbers? -4 and 9. Okay, y'all, all of you who have your cell phones out down to the side in your pockets and your laps on top of your desk, can you please put them away at this time? And by away, I mean either in my purse or in your backpack. I don't think you want your phone in my purse because I might take it home with me. Might take it right on to the house and you won't get it until tomorrow. All right. So like Marion said, okay, x is between -4 and 9. Let's put it on a number line first, shall we? Here's my number line. And y'all watch this. Oh, I meant to go back and show y'all on this previous one. If I were doing this on my paper, I would literally just write a little snack piece line like this, a 2, open circle, bop, 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 bop. That's all you got to draw. You don't have to do no whole big, long number line. Okay, y'all? You hear me what I say? All right. If you want to put a 1 here and a 3 here for context, that's fine too, but you don't have to. So with that being said, watch this. -4, 9. Boom. Naturally, the smaller number would come first, wouldn't it? Okay? Now, look at the inequality itself. Would -4 have an open circle or a closed circle on the point? It would be closed. Why? Because it has a line underneath. Valeria, keep doing this. Yeah? Does that make sense? Because we have the element of equality. Very good, madam. Because we have the element of equality, I'm going to have a closed point on -4. There it is. Okay? But what about 9? It's going to be open. Why? There's no line. We'll say that again. There's no line underneath. Yes, sir. I'm good. How are you? Yes. Yes, I'll write them fast. All right, thank you. Mr. Bright, will you write a pass for Chris to go to Dr. Nelson? He needs to see him real quick.
Yeah.
All right, folks. All right, so Emma was telling us that it should have an open circle on 9. Why again? There's no line underneath there, right? And what does that line represent? Equality. It's saying that X can be equal to something, right? It can't be equal to 9. So I have to have an open circle on 9. Okay? You don't have to make your circle so juicy like mine. Bless the teacher, y'all. Blessed assurance. All right.
You said Chris, yes?
Mm-hmm.
Chris.
All right. Now, what about the shading part? Well, X is literally right smack dab in the middle of -4 and 9, isn't it? That should be a clue that X is literally going to be in between these numbers. So we're going to be shading in between here, right? Because it says that X is less than 9. Well, where are the numbers less than 9? This way, right? To the left. And if you read the inequality going this way, X is bigger than -4, is it not? So where are the numbers bigger than -4? This way, right? Where do these two regions overlap? Right in between those two values, yes? Hello? So my shaded region is here. And you use slashes, you could use a highlighter, you can use the color pencils on your desk, you know. Make it pretty if you want to. All right, so we graph the inequality. Any questions? Don't need to press pause. Anybody need time to write something else down? May I proceed? Jamari? I need you, baby. May I proceed? All right, now, interval notation. Remember, it goes from the smallest number to the biggest number, right? What's the smallest number? Huh? Say it louder. Say it louder. That ain't louder. You just said it again. Say it louder. -4. Say it louder. -4. Dang. How you gonna be right and quiet? -4 is the smallest number in this situation, right? What is the biggest number in this situation? 9. All right. We're almost done with our interval. Now, look at -4. Am I including that value? Am I? Yeah, I know you did. Tell me why we're not including -4. I need math. I need some math. Look at that picture. What's going on above the number 4 on that number line? You see an open dot or a closed dot? If it's closed, what's up? Tell me. If it's closed, I want it. Okay? If it's closed, it has that element of equality, right? You feel me? And if it's closed, am I going to have a parenthesis or a bracket? Y'all, this Tiffany, she said. And she's absolutely right. Is Tiffany right? Yeah, she's right. Very good. A bracket, okay? Because there's a closed dot on -4. Michael, come here, come here, come here. Get your stuff. Get your stuff. Get your stuff. Come here. Get all your stuff. Hush up. He went on the phone. Right behind David. Right there. You need anything you bring? Did you bring your calculator? Just in case, sugar baby. That's gonna be your seat from here on out. You hear me what I say? All right, sugar baby. All right. So, looking at 9. Okay, look at 9. Do we have a closed dot or an open dot on 9? It's open. So am I going to have a parenthesis or a bracket on 9? Parenthesis. All right. Okay, that's interval notation, babies. Okay, that's interval notation. Y'all with it? Boom. That's it. And I always start with the smallest number and then go up to the biggest number. Okay? May I proceed? All right.
You're gonna have to solve it and then get down to the.
Why are you laughing like that?
Sugar baby, it ain't gonna be hard if you pay attention. It's so like, moving on. All right. Let's talk about domain, y'all. Draw a line, we're switching gears. All right. Let me highlight the fact that, okay, we just fulfilled the first objective. So go and put a check beside your first objective. We just learned how to convert inequalities to interval notation. All right. All right. Now let's talk about the domain and range. The next objective is to analyze the domain and range of a function. Let's go. All right. First of all, understand what domain is. The domain of a function, okay, is the collection of all possible x values, okay? The domain of a function is the collection of all possible x values. That's what the domain is. All right. What's wrong? Just take the roll over there with you, baby. Take the smaller one. I need to steal some more tissue, don't I? You not feeling well?
No.
You dragging like something wrong. Hurry up, I need to finish teaching. All right. And when you're looking at a graph, Jamari, when you're looking at a graph, the way that you determine the domain of that graph is by reading the graph from left to right. Jamari, go splash some water on your face. I don't need you to listen, man. I want you to write this down too. I want you to listen and write. You good? Okay. I'll give you a copy of what you missed. Matter of fact, I'll give it to you. The domain of a graph is determined from left to right. This is, remember, the smallest x value to the biggest x value, okay? May I proceed? Yes? All right. Now let's talk about the range. Well, if the domain is all possible x values, then naturally the range, Alexis, is going to be all possible what? Yeah, all possible y values. Okay. And the way that you determine the range of the graph of a function is by reading it from the bottom, okay, smallest y value, to the top, the highest or the biggest y value. You got it? May I proceed? Okay. Okay, baby. All right, let's do one. Look at this. We're gonna figure out the domain of this picture, right? Of this graph. Now remember, the domain is read from left to right. Now, what is the furthest most left point on this graph? Well, you got to think about it from side to side, right? I see a point here, and it ends over here, right? You see it? Now, what x value does this furthest left point line up with? Which one? What is that? Can y'all see that? What point? What value on the x-axis does this point line up with? And notice there's a coordinate -1, -5, right? So the smallest x value on this graph is -1, right? All right, so let me get back. So the first thing I'm going to write down, because I'm writing my domain as an interval, let me show you how to write it. On your paper, you're going to put domain colon, okay? The smallest x value on this here graph, y'all just told me is -1. Okay, cool. And it goes from -1 all the way over to where? Okay, let's see. Here's the point. That's the last point on the graph, right? Nothing else past that point. So let's see. It lines up with what x value? Just in case you can't see. Okay, lines up with 4. So so my domain contains all values between -1 and 4. All right, now I ain't putting out one bracket or parenthesis up here, have I? All right, now I need to go back to my points and figure that out. Now let's shimmy over there to -1. Do I have an open dot or a closed dot at -1? It's closed. So what should I have on -1? A bracket or a parenthesis? Oh, okay then. Let's make it happen on your paper. I said make it happen on your paper. Now, shimmy on over there to that last point. Okay. 4. The point 4 is 0. It is the furthest most right point on this graph. Does it have an open dot or a closed dot? Open. So what should I put on 4? A parenthesis. Boom, done. That's my interval for my domain. My domain contains all points within this interval. Every point including -1 to 4, not including 4. So -1, 0, 1, 2, 3, not including 4. Make sense? And remember, you read the domain from left to right. Is that clear? Everything in between there. Goes from -1 to 4. These are all of my possible x values. Does that make sense? All right. Same graph. But now I'm going to figure out the range. We're figuring out all possible y values. Now, how do you determine the range? I look from where to where? Bottom to top. All right. What's the lowest point on this graph? Say again. Be careful. Oh, man. Remember, we're dealing with range, so we're thinking about the y values, right? The lowest most point would not be -1. That's x, right? The lowest most point is going to be what? It's going to be -5. All right. And then the highest point is going to be what? All right. So I'm looking from here to here. That's what my graph is contained in between, right? Okay. So when I write out my range, y'all, I'm going to write the word range, colon. You should do the same. My range in this case goes from -5. Remember, you start with the smallest number first, right? -5, comma what? 4. Thank you. Now, am I going to have an open dot or a closed dot at -5? I'm sorry. Am I going to have, do I have an open dot or a closed dot at -5? It's closed. So should I have a bracket or a parenthesis? Bracket. Elijah, I should have a bracket. Pay attention, baby. You go splash some water on your face. All right. What should I have it for? Why? Because what? It's a closed circle? You're absolutely right. Very good. Boom. Got brackets on both this time, huh? Make sense, Grayson? Stay with me, baby. May I proceed, Alexis? I don't believe you. You got to convince me. I need to see your face. I can't see it. Because if I can't see your face, you can't see the screen. Yes, sir. Oh, okay. All right, may I proceed? All right. Boom, top to bottom. I'm sorry, bottom to top with the range. All right, now, specifically with polynomials, guys, okay? So we're not just talking about any old graph that I slap up on the screen. Specifically with polynomials. Here's another always situation. I might play the lottery today because I rarely say always, y'all. I done said it twice. Huh. Done said it twice. Lord have mercy. The domain, okay, all possible x values of any polynomial will always be all real numbers. Okay? The domain for all real numbers, I'm sorry, the domain for all polynomials will be all real numbers. Okay? I'm doing all this fancy notation. Forgive me. Negative infinity to positive infinity, right? Hello? Savage? Now, the range will be any of the following 3 combinations, okay? Okay? For any polynomial. It might be all real numbers. It might. Okay? Something was deleted. I did not mean to delete this. It might go from a lower boundary to infinity, like so. LB for lower boundary. Just a second. Just a second. Lower boundary to positive infinity. It may look like this. Or it may go from negative infinity to the upper boundary. Okay, go ahead and write that down, folks. Yes, ma'am. I do. Yes, thank you. And I'm going to show you examples of all 3 of these. Okay? Shantasia, come on, baby. Get these notes. I'm going to let you pass. All the way through slide. Slide 14. I'll just give you those. I'm not gonna give you anything else. Notes. Hold on, child. Where you going? Here you go, sugar. Make sure you go through those tonight, please, and thank you. Here you go. All right. All right, so can I show you the 3 examples of each of these instances with the range? Savage, I need you to pay attention, babe. All right, so here comes the first example for all real numbers on the range, okay? All real numbers on the range. Y'all still writing? Okay, I'll wait. Kendall, I'm bringing a swim cap. Get your hand out your field. Stay with me, Heaven. Y'all, spring break is almost here, y'all. Come on. It doesn't matter. It ain't soon enough.
It's not next week.
It sure ain't.
Is it in 2 weeks?
Baby, I don't even know. It's 5 months away. All right, let's go. So can I do the examples now? We good? All right. So the first example is all real numbers, right? Negative infinity to positive infinity. All right, just gonna grab good old fashioned x cubed. Boom. Can y'all see that? Let's see if I made it 1/3. That make it better. Yeah. It's a good old fashioned x cubed function. Do you see how it goes up and down forever and ever and ever and ever and ever, no matter how much I zoom out? Well, you can't see it anymore, but y'all get what I'm saying, right? This is an example of where the range, Michael, put it down, of when the range is all real numbers. It goes up forever and it goes down forever. Can you see? Any questions? Sketch this on your paper, y'all. Sketch this on your paper. Just draw a little ugly, look, a little quick and dirty situation like this. That's an example of where the range is going to be all real numbers, okay? Doesn't have to be cute. Doesn't have to be cute. All right, next one is when you have a lower boundary and it goes to positive infinity, right? All right. I'm gonna do a good old fashioned quadratic. Where's my graph? Oh, good grief, come on. Okay. Good old-fashioned quadratic, right? You see how it bottoms out at a certain point? Elijah, can you see it? Thanks for looking up. Take your hand off your head. Take your hand off your head, baby. Pick up your pencil. Okay, because you need to label this one beside the lower boundary to infinity, right? It can be any old ugly graph. Doesn't have to be cute. It's a situation like this. That's super ugly. But it has a lower boundary, LB, a lower boundary, right? And then it spikes up to positive infinity. That's a picture where your range has a lower boundary of whatever number, and it spikes up to infinity. Make sense? Okay? All right. Now the next one, I'm not gonna make it hard. Boom. Throw a negative symbol in front of x squared. Makes it flip downward. Right, Alexis? Alexis? Thank you for sitting up and paying attention. All right. Put your phone back in your bag. Phone in your bag, please. Thank you. So notice this one has a peak, right? So the lowest most point is going to be negative infinity. And then it goes all the way up to whatever this value is. It really doesn't matter what it is. But this is just a picture of where you would have a range that will start at negative infinity and go all the way up to positive. I'm sorry, all the way up to the upper boundary. Okay? So on your notes, you just draw a little raggedy picture like this. Graph, boom. And this is your upper boundary. Okay? That's super ugly. Does that make sense to y'all? The other one was too ugly. All right. Questions or concerns? Put that phone up. May I proceed? All right. You said no? And Elijah, here's the issue too. You can't sleep while you should be writing, and then the whole class has to wait on you to write because you were sleeping. You gonna write this down? All of it? Okay. Don't go to sleep anymore, okay? All right. Now, this situation right here made me want to get my purse to go home on the test because you all were asked to find zeros of various polynomials, okay? You were asked to find the zeros, and you all forgot that I told you that zeros, x-intercepts, solutions, and roots all mean the same thing, okay? When you're asked to find the zero of a function, you're literally figuring out where it crosses the x-axis. Please write this down. Michael, that includes you, baby. Jamari, that includes you, baby. Kendall, that includes you, baby. Savage, that includes you, baby. Write this down. What's a zero? Miss B, what's a zero? I was like, what do you mean, what's a zero? We've been talking about it the whole time. It's the same thing as an x-intercept, same thing as a solution, same thing as a root. And it's literally where the graph crosses the x-axis. Chris, write this down. All right, may I proceed? All right.
Guys, some of you are writing it down, some of you are not. But the line that separates the words, right? The line that separates the words right here, what is this? This is a what? The slash, yes? So when you're taking notes, what does that mean? What do they mean? What does the slash mean? It means the same, right? So if you draw an arrow, you could draw an arrow back and forth, or an arrow back and forth, an arrow back and forth. There's one thing I just hit it. Can you hit it back? My elbow, actually. So when you draw those lines, and teachers draw those lines, that means you need to be writing that too and drawing the lines so you understand that they mean the same thing. You can even put an arrow above it, back and forth. Please write this down.
Do you care to share who didn't write it down, Mr. Bryant? Or encourage them to write it down?
That was my encouragement. I saw about 3 or 4. Josh, show me yours. Where's yours? Show me. Show me. Put the lines, show me. Very good. Okay, now put the lines, let's go. Where's yours?
All right, Kendall, we're back at it. May I proceed? All right. So now, young people, we have the graph, okay? The graph of some given, obviously this is a parabola, right? Okay, cool, a quadratic. We've been asked to determine the x-intercepts. Well, literally, the x-intercepts are where? Elijah, what does the x-intercept mean? Very good. Now, where does this graph cross the x-axis? Boom, very good. Now, the only catch when they ask you specifically for the x-intercept is this, okay? Very specifically. They're asking you for the location of the place where the graph crosses the x-axis, okay? So how would I name this location? How do I name that location? How do you name a point on a graph? How do you name a point on a graph, y'all? Yeah, yeah. So what's the location of this point? 1, 0. What's the location of this point? 5, 0. Y'all know that's why they call them zeros, right? Because all along the x-axis, y is always equal to 0. That's why they call it the 0. Because that's where the function itself is equal to 0. That's the connection. Does that make sense? Okay. If they just ask you for the root, okay, if they just ask you for the root, what could you put, or what should you put? Just put 1, 5 and be done with it. There's a root at 1 and 5. Does that make sense? But if they ask you for the x-intercept specifically, you're going to write a point. Do you see the difference? Okay. Same with zeros. If they ask you for the zeros, you just put 1 and 5. Boom. May I proceed? I will wait on Michael. Michael needs to wait. Elijah, go splash some water on the thing. Hurry up. All right, here we go. Look at this one. I could have sworn I erased this, y'all. Hold on. Then gave y'all the answer and everything. Not that y'all need it. Not that you need it. All right, so what are the x-intercepts here? Hard to see. I'm going to put the numbers in for you. That's -4, -3, -1, 0, 1, 2, and 4. So the x-intercepts will be located where? You're going to write x-intercept. -2 what? Thank you. I didn't ask you for the roots, did I? I asked you for the intercept. When I asked you for the intercept, get the point. Very good, Miriam. But if you said -2 and 3, you're halfway there, right? All you got to do is just name the full point. That's all. All you got to do is name the full point. So it's -2, 0, and where else? 3, 0. I hear you, Marion, whispering very softly. Does that make sense? So naturally, the zeros, Alexis, will be located where? What will be the zeros? I said what would be the zeros? -2 and what? I'm naming zeros. You close the door, please. -2 and who? 3, that's it. Okay, -2 and 3. They listed it twice here because this is a situation called multiplicity. I will speak about multiplicity in detail later in the week. All right. Moving on. What are my zeros? And 2. Very good. My zeros are -1, 1, and 2. What are my x-intercepts? Excuse me? What are my x-intercepts? -1, 0. Remember, you got to give me a point. Okay? My x-intercepts are located at -1, 0, 1, 0, and 2, 0, right? But my roots and my zeros naturally would just be -1, 1, and 2. Make sense? Okay. Let's talk about the y-intercept. Let's talk about the y-intercept. The y-intercept, young people, is where the graph naturally crosses the what? The y-axis. Write this down, please. Please write this down. Please write this down. Please write this down. Please and thank you. Please and thank you. So, as you write it down? Okay. Yes. Yes, ma'am. Only if I can come with her. All right. Thank you, babe. Valeria. Ms. Wright, will you write her a pass, please? May I proceed, young people? I said, may I proceed? Alexis, I could have sworn I told you to put your phone in your bag. Thank you, Alexis. Thank you, Alexis. All right, so naturally, young people, if the y-intercept is where the graph crosses the y-axis, okay? I know it's hard to see. Let me see if I can zoom in. Y'all see that? Where does this graph cross the y-axis? At -12, okay? So naturally, the y-intercept would literally be that point, right? So how would I name that point? Okay, the y-intercept would be located at the point 0, -12. Does that make sense, Alexis? Sit up, baby. Thank you. The coordinate would be 0, -12. Any questions? All right, next one. What about this one? See, and they're counting by twos, y'all. So it goes 0, 2, 4, 6, 8. So where or what is my y-intercept? 0, 2. Very good. Very good. Thank you for making that switch, because I had a student to say 2, 0. Remember, the x value comes first and the y value comes second, right, Kendall? So the y-intercept would be 0, 2. Okay. All right, Heaven, sit up, baby. Kendall, you got to look up here, baby. You're not even looking. Blessed assurance. All right. So this is where I stopped with the other class, right? So at this time, young people, I'm going to give you back. Hold on, let me stop the recording. What do we have, about 12 minutes left? So it's about in keeping with everybody else.